So we have arrived at our final lesson in Unit 1, and we are on Section 1.4, Rewriting Equations and Formulas. So we're going to talk about another new kind of equation called a literal equation. So basically you'll know something's a literal equation if it has if it has two or more variables. I know you're used to just having one variable to solve for. With these, you're going to see that you have multiple variables and you just pick one to solve for. Usually you're told which one. And basically you're going to use the same exact steps that you've used and have learned so far. So this first set here, it says, let's try a few, solve each equation for y. So when you look at this first example, we see that there's a y and there's an x. That's how we know it's literal. I've asked you to solve for y. If you're solving for y, that means that you want to isolate the variable term first. So that means I want this 5x to go away. If you want to cancel something out, remember you add the opposite of it, right? So I'm going to add a negative 5x. I'm left with 2y because 5x plus negative 5x is gone. And I'm not left with just x. You can't take 6 plus negative 5x and combine it because 6 doesn't have an x. So I'm just going to rewrite this. 6 plus negative 5x. Now I still haven't solved for y because it's not by itself, but to get y by itself you would divide by 2. If I divide this side by 2, that means I need to divide that entire side by 2. So those are gone and y is going to be equal to, and this is where I see some troubles begin. If I'm dividing this whole side by 2, that means I want to divide each term by 2. So that means I need to take 6 divided by 2 plus this negative 5x divided by 2. And I, of course, want to put that in simplest form as an answer. So y will be equal to, 6 divided by 2 is 3, plus negative 5 halves is, of course, equal to negative 2.5x. If you wrote minus 2.5x, yay, that's just fine. It's the same thing. Okay, let's try a few more. These are kind of tricky. So next one, again, I am solving for y. I'm going to add the opposite here. So that means step 1, I want to isolate my variable term. That means I want this negative x to go away. I mean, who doesn't want their negative x to go away? So to get rid of this negative x, I will add a positive x, and that will cancel them out. I'm left with 5y. And over here, I still have 10 plus x. I cannot combine them together because 10 doesn't have an x. I want the y by itself, so that means I need to get rid of this 5 that's being multiplied. That means I have to divide by it. That means I have to divide both of these terms by 5. So if you want, instead of writing like I did last time, I just wrote the 2 underneath, I can do this. I can say 10 divided by 5 and divide the x by 5 as well. Either way is fine. And y is equal to, let's simplify this, 10 divided by 5 is 2. And then x fifths, I can't really do anything with that. It does mean 1/5 x, same exact thing. But now we're done. We've solved for y. Let us try another one. I'm going to add the opposite here. Again, if I'm solving for y, that means I want this variable term alone. That means I want 4x to go away, cancel out. So I will add the negative version of it because that will make it cancel out. 4x plus negative 4x, gone. I'm left with negative 4y because remember 4y was being subtracted. And over here I have 1 plus negative 4x. I can't combine those together again because the 1 does not have an x. I now want this negative 4 to go away. It's being multiplied, so I will divide by it. I'm going to divide that by negative 4. That means this needs to get divided by negative 4, and so does that. So, negative 4 divided by negative 4 is 1. 1y is y. I have 1 divided by negative 4. I'm just going to call that negative 1/4. Plus, negative 4 divided by negative 4 is 1, and 1x is x. If you wrote y equals x minus 1/4, you are also correct. It's all good. Alright, last one like this, and then we'll talk about some formulas. I want this 3y to be by itself because I'm solving for y. So I'm going to get rid of this positive 6x by adding a negative 6x. Those will go away. 3y will be left, and I have 12 plus negative 6x left on this side. Again, I can't add those together because 12 does not have an x. So now, I'm going to divide this side by 3 so that I can isolate the y. That means this needs to be divided by 3, and so does that. So 12 divided by 3, that's 4. Negative 6x divided by 3, well, negative 6 divided by 3 is negative 2, and I still have my x. Those, of course, equal 1. 1 times y is y. So y is equal to 4 plus negative 2x, or 4 minus 2x, or if you want the y on the other side, so be it. It's all the same. Okay. Now, generally when you're solving for area, you'd want to leave the formula as area equals base times height. If you're looking for a rectangle, of course you know that there are other area formulas for other shapes, but let's say that I was given the area and the height, and I wanted to figure out what the base was. Well, this allows you to do that. So if I wanted to solve for b instead, I have this formula a equals bh, which means base times the height. If you want to isolate the b, then that means I need to get rid of the h. Well, if I had like 5b over here, wouldn't you just divide by 5? So in order to get rid of what b is being multiplied by, all you need to do is divide by it. So if I want b alone, I can divide this side by h, because h divided by h, even though I don't know what it is, I know any number divided by itself is 1. So now b is alone, and if I divide this side by h, that means I need to divide that side by h. Now at this point, you don't know what a is and you don't know what h is, but you do know that a divided by h will give you the base. That's all you do. For real. That's it. Let's take a look at this one. I know you are all familiar with the simple interest equation because that was a whole skill packet for you. But in I equals PRT, let's say we wanted to solve for P. It sounds kind of funny, but I'll let it go. So I'm going to rewrite this. I equals PRT. I want to get P by itself. Now currently these are all being multiplied over here, and you know that when you divide a number by itself it's 1. So instead of just dividing by H in the other one, I want P by itself, so I'm going to divide by R, and I'm going to divide by T as well. Because R divided by R is 1, and T divided by T is 1, and P times 1 is P. Now if you divide that side by RT, we have to divide this side by RT. And I don't know what any of those values are, but I do know that P is equal to I divided by RT. Alright, moving along. This one is a doozy. Hopefully you will love it. This is one of my favorite kinds of problems. The nice challenging, but when you get to the end, it's like, yay, I did it. Okay, the formula for the surface area of a cone, and this is really the formula for the surface area of a cone, it's surface area equals pi times the radius squared plus pi times the radius times z, and this just means slant height. So I want you to take this formula and I want you to solve it for the slant height. So I'm going to rewrite this to give us some space and draw my line. Okay, so this time the variable term, it's the one containing that little swirly L looking thing. So I'm going to start off by getting this by itself on one side. That means I need this to go away. Well, if this was 5x, wouldn't you just add a negative 5x? But it's not, it's pi r squared. So I'm going to add a negative pi r squared. I'm going to do that to both sides. Now when you do that over here, those do cancel each other out. When you add opposites, they're gone. And now I'm left with pi r L. Pi, radius, slant height. Here, those are not like terms, so I'm going to write s plus negative pi r squared. Okay, now I want this L by itself. That means that I need the pi and the r to go away, right? Since they're all being multiplied, to undo that multiplication, I divide. And I know if I divide pi by pi, I get 1. And if I divide r by r, I get 1. And 1 times L gives me the L. So I'd have L by itself. If you divide this side by pi r, that means I need to divide each term over here by pi r. I know this looks so complicated, but it's not so bad, right? So S divided by pi r, there's not really much I can do to simplify that. I don't know what S is, I don't know what R is, and I'm not going to write the whole amount for pi because that would take forever, literally, because it never ends. So I'm just going to rewrite S over pi times R. Now, over here, there is some work that we can do. If I know that any number divided by itself is 1, then this pi divided by pi, or negative 1 pi divided by 1 pi, is gone. I'm left with, I still have this negative 1 here. And I have 2 r's that are being multiplied here and 1 r here. And we're going to have a whole chapter on the laws of exponents, but here's your intro. If you have r squared actually means r times r, right? Now if I divide one of those r's by itself, it's gone. So you can see that I am left with negative r. So I'm going to write that down. So the answer is slant height is equal to surface area divided by pi r plus negative r. I wasn't kidding. I told you that one was a doozy. Okay, let's try the last one here. The formula for converting degrees Fahrenheit to degrees Celsius, it's given right here. Solve the temperature formula for F. So again, if C equals 5/9 times F minus 32, I want to get this F all by itself. Okay? Now, do you see how those two are being multiplied, not added, the 5/9 next to the parentheses? I know normally when you see this, you would want to distribute the 5/9. And you could totally do that, and it would work, but I have something that would take a much shorter amount of time. When you notice that the terms are being multiplied, not added, this is actually one big old term. We learned that to get rid of a fractional coefficient, we can call this a fractional coefficient because this is in parentheses, we multiply by the reciprocal, right? So I'm going to multiply this side by 9/5, and then I'm also going to multiply this side by 9/5, because whatever I do to one side, I have to do to the other side. So 9/5 times C is just 9/5 C. Over here, 5/9 times 9/5 is 1, and I'm left with F minus 32. Now I want F by itself, so this was F plus negative 32, I'll call it. So I just need to add 32, add 32. F is by itself, and over here I'm left with 9/5 C plus 32. Those are not like terms. They cannot be combined. That means we are done. I will see you tomorrow.